Okay, in this example, we have a package of aluminum foil and it contains 50 square feet of foil, which weighs approximately 8.0 ounces. Aluminum has a density of 2.70 grams per centimeter cubed. And what is the approximate thickness of the foil in millimeters? So here are three different conversion factors. These would all be provided on one of my exams. And so we will be able to use these. Okay. So the first thing we want to do, if our density is in grams, let's convert the other weight we have also to grams. So we'll take our 8.0 ounces, and we're going to use this unit conversion. As a reminder, unit conversions have infinite number of significant figures, so anytime we want to calculate our sig figs, these will not be utilized, just information provided in the problem. So using this, we know that 1 ounce is 28.3495 grams. So we take 8 and we're going to multiply that by 28.3495. And we have 226.796 grams. Okay, so now we can actually determine, first, we also need to determine how many square centimeters we have here, since this is in square centimeters. And as a reminder, this is length times width times height, and so we already have the length and the width. Okay, we're going to convert 50 square feet to centimeters squared. So when we do unit conversions, we know that 1 foot is equal to 12 inches, but we have feet squared, and so we need to square both of these values. Now we're going to convert to inches, or from inches to centimeters. Okay, so in this case, when we plug this into our calculator, we get that 50 times 12 squared times 2.54 squared is equal to 46,451.52 centimeters squared. You might be asking, why are we continuing to use all of these numbers if there are only, at best, 2 significant figures in this problem? It turns out we always want to keep all of these, what will eventually become non-significant digits, for the entirety of the problem so that we can use them to make sure we have the most accurate number. Okay. Now we can use our weight to do a density calculation to determine the volume of our foil. Okay. So we're going to take our weight here, which is 226.796 grams, and we are going to multiply that by the inverse of the density, which is 2.70 grams per 1 cubic centimeter. Okay, and so we take 226.796, we're going to divide by 2.7, which gives us 83.9985 cubic centimeters. Okay, so if we know that the length times the width is this, we can now determine the number of centimeters that are in the height and convert that to millimeters. Okay, so we're going to take our 83.9985, which is equal times the length times width times height. But we know that the length times width here is actually this number of centimeters. So in this case, the height of this is we're going to take this 83 number, we are going to divide it by 46451.52. We're going to get 0.0018083 centimeters. But the question has asked for this in millimeters, and so we need to do a small unit conversion. So you may notice that in your provided values, the millimeters to centimeters is not provided because you are required to memorize the prefixes, okay? So if we take our centimeter value, we need to convert that to millimeters. So in 1 centimeter, there are 10 millimeters. We're going to multiply this value by 10, and we get that there are 0.0018083 0.01883 millimeters. But this probably has too many significant figures. So we take a peek back at the problem when we have 3 sig figs, 2 sig figs, 3 sig figs. So we need a value with 2 significant figures. Now we have this value, and so leading zeros at the beginning are non-significant. So we are going to count these 2 values. So our sig figs is 0.018 millimeters is our final answer.